Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my channel Fun Mechanics. Today we will be solving example 12.2 from Engineering Mechanics by RC Hibbeler 12th edition. So the example states a small projectile is fired vertically downward into a fluid medium with an initial velocity of 60 meters per second. Due to the drag resistance of the fluid, the projectile experiences a deceleration of a is equal to minus zero point 0.4 velocity cube meter per second square, where v is in meter per second. Determine the projectile's velocity and position for second after it is fired. So here it states that a projectile is fired vertically downward into a fluid. So when the projectile passes through the fluid, it slows down due to the drag resistance of the fluid. So here it says that the acceleration is given as 0.4 velocity cube meter per second square, and we have to find out the projectile's velocity and position after 4 seconds. So let's solve this problem. The acceleration is given as minus 0.4 velocity cube meter per second square, and as we know that acceleration is dv by dt, rate of change of velocity with respect to time. So we can write 0.4 velocity meter per second square. Now we have to find the velocity, so we can move this term to this side, minus 0.4 velocity cube, and we will move dt to this right side. After that we will integrate on both sides. Now putting the limits 0 to t, and for this we will put the limits initial velocity, which is 60 meter per second, to find some final velocity which we have to find out, which is v. Now this problem is about integration. If you are good in integration, you can easily solve this problem. So we will integrate this step by step. First take out the constant minus 0.4, we took out minus 0.4 to the outside, and then we will integrate 60 to v, 1 by v cube into dv is equal to 0 to t into dt. Now this v cube is basically v power minus 3, and after integrating it becomes 1 by v square, and into minus 1 by 2 will be taken out, so we can write minus 1 by v square, and we will put the limit 60 to v, and here it becomes t 0 to t. So basically it becomes t, but after putting the limits, so here it is 1 divided by 0.8, and after putting the limits 1 by v square minus 1 by 60 square, and here it is t. Now we have to find this velocity, so we will take velocity to the right side and all the terms on the left side, so it becomes 0.8 t. When this will go in this side and we multiply it, 0.8 t plus this term will go to this side and will become positive 1 by 60 square is equal to, and this will remain in this side, so 1 by v square. We can also write this as v square is equal to 1 by 0.8 t plus 1 by 60 square, and velocity becomes under root 1 by 0.8 t plus 1 by 60 square. After putting t is equal to 4 seconds as given in the problem, we can find velocity plus 1 by 60 square under root. I am writing directly the answer, you can calculate step by step. So velocity becomes 0.559 meter per second, and this is the final answer for the velocity. It also has asked to calculate the position, which is basically s, and as we know that velocity is equal to ds by dt. From here we can find the position or the displacement. V into dt is equal to ds, and as we have solved previously, we have found that the function of velocity is this. Putting this in the below problem, in this equation, we can put 1 by 60 square plus 0.8 t power 1 by 2, sorry, minus 1 by 2 into dt is equal to ds. So here we can integrate on both sides. Integrating on both sides, the limits here will be 0 to s, and from here it will be 0 to t. Now we have to solve this. First we will solve this step by step. Here we can substitute u is equal to 1 by 60 square plus 0.8 t. So putting this in the above equation becomes u power minus 1 by 2 into dt. So u is equal to, and du is equal to 1 by 60 du by dt 1 by 60 square plus 0.8 t, and we have to take the derivative with respect to time. So it becomes du is equal to 0.8 into 0.8 into dt. Substituting here, the dt becomes du by 0.8. As we can also write this du 0.8 is equal to dt. So we have this equation 0 to t is equal to 0 to s into ds. Now we can put this term outside, so it becomes u power minus 1 by 2 du 0 to t into 1 divided by 0.8 is equal to 0 to s into ds. So what does this term becomes? It becomes u power 1 by 2 divided by 1 by 2 0 to t into 1 by 0.8 is equal to 0 to s into ds, and it becomes 2 by 0.8 u power 1 by 2 0 to t. Here becomes s 0 to s. Now putting this value again, 2 by 0.8 1 by 60 square plus 0.8 t power 0.8 t power 1 by 2, and putting the limits 0 to 4 here as. Now after putting the limits, we get the answer as it is solved in the example. Like here s is equal to, in the second last step, s is equal to 2 by 0.8 1 by 60 square plus 0.8 t over 1 by 2 0 to t. Now after putting the limits, it becomes, here we have 0 to 4, 1 by 0.4 1 by 60 square plus 0.8 t over 1 by 2 minus 1 by 60. As if you put 0 in this step, 0.8 t terms cancel become 0, and we have 1 by 60 square. So after putting the value of t is equal to 4 second, we will get the displacement s is equal to 4.43. You can solve this step by step, or we can also do this 0.4 and 1 by 60 square plus 0.8 t. Here we will put t and over 1 by 2 minus 1 by 60 का square and 0 to t. When t is equal to 4 second, s is equal to 1 by 0.4, 1 by 60 square plus 0.8 into 4, 1 over 1 by 2 minus 1 by 60 plus 1 by 60 square. Sorry, here I have also put the limits, which will not be necessary because we have put the limits. So here we have the answer as given in the example to be 4.43. So in this way you can find the velocity and displacement if you have given the acceleration, or similarly if you are given the velocity you can also find the speed or the acceleration, and vice versa. So thank you for watching. This is all for it. In the next video we will solve the next example 12.3.